Good morning, everyone. At Deloitte, we do a fair amount of AI projects. Maybe not as much as I would like, but we do a fair amount. And one of the reasons that we may not do as many as I like is that some of our customers, some of our clients are wary of AI. They're a little bit scared. And I tell them, no, it's okay. But in fact, there are some reasons why you might want to think twice about using it. And I'll try to explain a couple of these reasons today and what we can do about it. I realize this is a really international and compared to me, fairly young audience, but if you're Dutch, and if you're about my age or older, so really old, then my name may strike you as familiar, and that's because my mum used to be on television. And my mum, she was a wise woman. She taught me many things, but and she was also, apart from being on television, she was also an entrepreneur. She had her own business. And when I started my business, way back when I started, I had a small startup, she told me something about hiring staff. And she said, Evert, when you're hiring staff, what you want is you want smart people, and you want diligent people, right? You don't want lazy people, and you certainly don't want stupid people. But the worst thing, she said, the worst thing that you can have is somebody who's stupid and diligent, because they will trip you up every time, right? And in a way, what we're building with AI, or the risk we run, what we're building are stupid, but really diligent agents, right? And let me tell you a story this is not my story. This is a story that I was told by Rich Karwanov of Microsoft, and it involves predicting mortality for pneumonia. So pneumonia is evidenced by this poster from the 1930s, I think. Pneumonia is a very serious and potentially lethal condition. Right? About 10% of people who contract pneumonia actually die from it. What he had to do was, it would be a Kaggle competition in these days. He had to build a model, to develop a model, jointly with some colleagues, to predict whether somebody would die from pneumonia, to predict the risk of dying, so that these patients could be triaged. Because if you're at risk, then you have to go to ICU, to intensive care, and you have to be treated really, really thoroughly, immediately. But if not, then basically it's, take some antibiotic, go home, and call us if you're not feeling better in 3 days. So he had this data set. Well, you can imagine the data set. All kinds of measurements of the blood measurements, patient histories, all these kinds of things. And he built this model, and he used a neural network. Right? And he built this neural network, and it worked really, really well. 95% AUC. So it was almost too good to be true, but it was fine. And then the doctors asked, the medical doctors, they asked him, so Rich, what do you think? Should we use this model to start triaging our patients? Because it's better than us. Because doctors were, I don't know, maybe 80% accurate. Should we start using this for triage? And Rich said, well, no. Why not? Because one of the other models that had been built was a model that was explainable. So Rich had a neural network, famously black boxy, very hard to understand what's going on. But one of the other models was explainable, and that had found that people with asthma have a very low probability of dying when they contract pneumonia. Now, that doesn't make sense, right? Asthma is a sort of continuous inflammation of the lungs, and then you add pneumonia to that, and that's good for you. Doesn't really work out. And it turns out that this data set that he'd been training on was the data set of all the patients that they had treated, right? And what happens is, when somebody with asthma comes to the doctor and the doctor diagnoses pneumonia, they're sent to ICU immediately, because it's a complicating factor. So the risk is actually much higher when you have asthma. But the net effect of that is that people who have asthma actually are treated better than the average patient. And in fact, that reduces their risk of dying. Also, they're more likely to go to the doctor if they notice something wrong with their lungs, because they're aware that they already have this condition. Right? So if you were to start using a model like that in anger to really triage patients, then patients with asthma who have a higher risk of dying actually would be sent home, right? So the models that we build, these models, they have no conception of the context that they're used in, of the implications of their predictions or classifications. And we need human intelligence, doctors in this particular example, to tell us, or to decide on the context around these models, to use their human common sense whether these models should be applied in particular cases. And the thing, of course, is that the data that we train these models, and so the models are biased because the data is biased. Machine learning methods aren't biased, or they're really bad. But most machine learning methods aren't biased in themselves, but the data is biased. And the data is not collected for the purposes of building a model. And it would be unethical in most cases. It would be unethical to tell asthma patients, well, sorry, you're in the control group, you're going home, right? You have to treat them. And stories like this abound. And that's the first reason that we need to be able to explain these models, that we need to be able to explain AI. So there's books out there with all these examples. Today, International Day of the Girl. Yesterday, the news broke that Amazon is discontinuing their AI-based agent for selection, for employee selection, because it was biased against women. Now, there's a lesson there. The first is, well, okay, so apparently the data that Amazon used is biased against women. So this tells us something about the bias that's already in there. So Amazon used to be biased against women. So one of the good things about building models like this and analyzing them is that you can detect these biases in your data and that you can do something about it. But you can't, if you just continue to use that bias, then you just continue this cycle of inequality. So that's the first reason. A second reason why we want transparent or explainable AI is that we want to understand when these models fail. And these models will fail. They may be more accurate than humans, they may be faster than humans, but they will make mistakes. Right? And the images that you see here on the screen, these are images that were generated. So this is a funny example of setting up AI to fool AI. This was research by Jason Yasinski, Jeff Kloon, and I forget his first name, Nguyen. And they built, using evolutionary algorithms, they built a system to fool one of the state-of-the-art image detection or image recognition algorithms out there. This was a couple of years ago. I don't know which neural network they had classifying the AI, but the neural network was supposed to be really, really good. And well, you can see these images here, right? So this is obviously a sea snake, obviously, right? Or a panpipe. It's clear as day. And the thing is, this neural network, this model, was more than 99% confident for each of these. It was more than 99% confident of its classification. So these models, they make mistakes, and they don't. In fact, they will tell you that you are wrong. I could mention US politicians to do the same thing. Right, so these models are wrong. The good thing is they are wrong they make consistently the same errors. And if we can explain when they make these errors, why they make these errors, we can do something about it. We can deal with it. And finally, we need to understand individual decisions. Right? We need to be able to explain why somebody wasn't hired, why we're not admitting somebody in some program, why some customer has to pay a higher fee than another if we have, for instance, if we talk about insurance claims. And computer says no is not a valid explanation. Right. And it's not just to be able to explain to clients, to customers, but it's also if we use, for instance, the Dutch railways, the trains are driving in the back here. The Dutch railways, they use AI systems to predict engine failure. It would be really cool if such a prediction is accompanied by an explanation of what it expects to go wrong, right? That it makes the engineer's job, who have to sort of prevent this from happening, makes their job a lot easier. So that's why we need, that's the third reason for explainable AI. So 3 reasons I gave you. To combat or to detect bias and inequality, to understand when you can and when you cannot rely on models, and to explain individual decisions or predictions. Okay. And state-of-the-art models, deep learning, neural nets were mentioned a lot yesterday. They're not transparent. When you talk about analyzing text using neural networks, then first there is this encoding, word-to-vec encoding. I don't know if any of you know what this is, but this is an example of word-to-vec encoding. And you talk to experts about this, and nobody will be able to tell you why these values are there or what they mean. They will be able to tell you how you can add these values, how they tell you something about phrases that are more similar or have similar meanings. But what the numbers mean, nobody knows. Neural nets for visualization. OxfordNet was, up until fairly recently, was one of the prime models for image classification. And if you ask somebody to explain, so how does it tell cats from dogs? You get this image. Well, some of us may think it's a nice image, pretty image, but having it as an explanation doesn't work for me, at least. Okay, so I'll give you there are 3 kinds of ways of dealing with this, of trying to analyze these models. And the first sort of set of methods to achieve transparency is to analyze these models. So you have to understand what these models look like, how they operate, how they work. And for instance, there's Garson's method where you analyze the weights of neural networks. Or if you have random forests, and you can look at the correlation of particular predictors used by these models. And this combined with your understanding of how these models function, how these models operate, can tell you something about whether they use reliable data, whether they detect interactions, all these kinds of things. But it's one aspect, right, of understanding a model, but it's not enough, right? And if you only do depending on the scenario, this may be exactly what you need, but there are other ways of looking at it. And if you do only this, right, only this kind of analyses. Then it may be even worse than not understanding the model, because you think you understand the model, but you only see the tip of the iceberg. There's only a part of it that you understand. You have to realize that. The second set of analyses is basically statistical analyses, like scoreband analyses, profiling of particular classes that are identified by your model. And this will help you. This can help detect bias, for instance. And it will help you detect, okay, so which kind of customers will I allow, which kind will I not allow? It will give you some indication of what kind of groups your model is detecting, what kind of predictors are the most relevant, and this will help you assess the implications of using your models to some extent. It's very tricky, these kinds of methods, and for all of them actually, to model all the interactions in the data that your models may have. And this also goes for the final set, the third set that I have, which is trying to sort of set a thief to catch a thief, where we have these. So you build your model using your black box method of choice, and then you build another model, but using a transparent and explainable method. You build another model that tries to mimic, that tries to approximate this black box that you have. Right, and there's a couple of examples. So this has been going on for years. So it used to be decision trees. Now there is. So the top image is an illustration of a method called LIME, right, which uses slight modifications of individual decisions, and then by sort of small perturbations of the data, slight modifications, it allows it to make a local approximation and say, well, in this particular case, if you were to apply for a smaller loan, or if this patient had a different blood value of some type, then it might be another case. So it will tell you at local level. So this works very well for individual decisions, less so if you want to see the overall picture. It will give you an indication of which predictors matter and how they influence that prediction. The bottom set is a couple of images provided by Rich Caruana, who I mentioned earlier. And he uses general additive models to approximate these black boxes. And he has this neat trick, and I'll spare you the details. He has this neat trick where you can also model some of the interactions, at least some of the binary interactions that are in these models. Right? But the thing about these transparent approximations is that they are typically fairly, because they are understandable, they're models that have fairly limited capabilities of expressing all these interactions in the data, because these interactions are what make it so hard, right? So they will never, well, if they're 100% accurate, then you don't need the black box. You can just use your general additive model. But they will never really capture all of the detail. But they will go a long way. And this will help you understand which predictors matter, also how they matter, and when they matter. And it doesn't have to necessarily be linear. It can be nonlinear, as we see in this small graph here, which is, well, actually it's about age and pneumonia, the probability of dying of pneumonia related to age. So they also give you a part of the puzzle. So there are three families, three methods of achieving transparency. Trying to analyze the models, how do the models work? Analyzing the weights of the neural nets, those kinds of things. Statistical analyses, what do particular classes of cases as classified by the model look like? Which are the most relevant predictors, all these kinds of things. And finally, these explainable approximations. And each of these is a part of the puzzle of understanding how these models work. And depending on the application, you may need one of them, all of them, none of them. But I think that for every application that matters, you really should check whether you need them. It should be a conscious decision whether you want to use explainable approximations to understand your model. Right? And I'm very skeptical about this trend. So it's great that AI and machine learning that is becoming commoditized, and we can use all these great APIs. But we have to understand these implications, right? And I'm very skeptical of this. Get the data, press a button, get the model, which some software vendors are starting to sell. Okay. Concluding, we need transparency. I hope I made that clear we need transparency to understand the models, to understand their implications, to be able to explain when models are wrong, to be able to explain why models make certain decisions or predictions. There's a lot of stuff out there right now, that, as I mentioned. There's a couple of techniques out there that will help us do that. And new ones will be developed. If the field of explainable AI sort of moves along on a par with the rest of AI, then I'm sure that in a year from now there will be 50 new methods, and they will be great. And so there's a lot of work going on there. These methods allow humans to understand how these models work, and we need human common sense, human insights of the implications of using the models to be sure that we're not magnifying inequalities, that we're not suddenly not hiring girls, all these kinds of things. We need to understand, we need to have human insight for this, right? And finally, and this is maybe linking a bit to the sort of auditing history that we have in Deloitte, of course, we need a methodology. Right? We need to make these methods that I just showed you part of our standard methodology of developing AI models, or machine learning models to be more precise. And when my children are a little bit too young now to appreciate any advice I might give them on hiring people, when they're older and if they start a company, I will tell them what my mother told me. And I will tell them that you don't want stupid and diligent staff. But I will say, well, if you do have stupid and diligent staff, it's okay, just as long as you know exactly what they're doing. Thank you very much.
Evert, thank you so much for that presentation. Good of you to be here. As we did yesterday for those new arrivals, we have an opportunity to ask you to put some questions for the content that you've seen today. And by doing so, just raise your hands, stand up and let us know where you're from. And we've got lots of roving microphones. So I've seen a hand just over there, so we're going to make our way to you. Anybody else like a question this side, raise your hand. But a microphone's just coming to you over there. Thank you.
Hi, I'm Joost Thunderbird. Thank you for this wonderful presentation. I was wondering, is transparent and accountable AI in principle possible for each and every AI strategy and application, or are there limits to it?
I'm sure that there are limits to it. Like I said, if you have these explanations, for instance, these approximations, they can't, by nature, they can't capture all of the interactions in the data that really complex models may find. So I'm sure that there are models where this can't happen, and whether that's an issue depends on the application. Right? So if it's a model that decides whether something is a rocket and then shoots at it, these models exist, they're working right now, then I would want to understand that model. If it's a model that decides whether the dishwasher should ask for new detergent, should send a message to Amazon for new detergent, I could care less.
I hope that answers your question. Oh, my microphone. Ah, hello. I hope that answers your question. Thank you very much. Any other questions here? Hi, gentleman just over there, and we'll come to you as well. Thank you.
Hello? Yes. Thank you very much for the interesting talk. I know you are also a professor. You teach me also the machine learning. So my question to you is, how do you feel we should go about teaching the business society about these tricks and these methodologies, which they probably have missed, or some of them have missed in their studies?
Well, that's one of the reasons that I went to Deloitte, is to be able to do this. Like I said, there's a lot of traction into this, into using AI. It's being commoditized. We get all these APIs, 5 lines of Python, and there you go. But we need to talk. So at Deloitte, what we do is we talk to management, to higher level management, and we try to explain why they need a methodology. We try to explain why you need to be able to audit these models, why you need to be able to understand what they do and their implications. So we have to evangelize, as it were. That's what I try to do. That's why I'm here.
Thank you. Thank you very much. And the final question here. Thank you.
Hi.
Can I just ask you to stand up if you wouldn't mind, just because of a lovely...
Yeah, sure. So I'm Hugo Valk, working for Randstad Group Netherlands. I had a question for you. Yesterday we heard the lady from Google, forgot the name, sorry, saying basically that we need AI solutions to solve what she's called like ineffable problems. So problems that we cannot rationalize how to solve. How does that compare to your need for explanations? And do you think that we will have the need for explanations so much in the future, say like 10, 20 years?
That's a very good question. To start with the last bit, yes, I think we will. I'm skeptical of this vision of AI that is, of general AI, that would also have a moral compass to use and the common sense to use these models. So I think that there will always be a need for humans to assess whether AI is doing the right thing. Like I said earlier, like in my previous answer, some cases are just maybe too complex for our little minds to comprehend. Well, speaking for myself here. They may be too difficult. And the question then is, are we comfortable relying on something that does something we do not understand at all to make decisions or to control some process that might be vital? And, well, I suppose we all have to make our own judgment there. But me personally, I would be fairly hesitant, right? And there are, well, so a lot of the proofs, let's say, of the relevance of AI now, or of the trustworthiness of AI, are in just trying it many, many, many times, right? So everybody who drives a certain brand of self-driving car can engage the autopilot. It will say it's better. So you're testing for the rest of us.
Okay, we'll have to leave it there if that's okay. Thank you so much for all of your questions. You're hanging around, aren't you, today, Evert? So if anybody wants to come and chat to you, they can do so.
Will do.
Wonderful.
Yep.
Thank you so much again.
Thank you.
Evert Haasdijk there. Thank you.